Welcome to Pre-Calculus Lesson 3.1, Video Notes on Exponential Functions Part 1. Our learning target for this one is to evaluate, analyze, and graph exponential functions. An exponential function has a base and has this form: a scalar multiplier on the base raised to the exponent, that the exponent being our variable, where x is any real number and a and b are real number constants, as long as they do not, a does not equal 0 and b is positive. Also b cannot equal 1. Here are some examples: f of x equals 4 to the x, f of x equals 1/3 to the power of x, f of x equals 7 to the power of the opposite of x. Non-examples: 2x to the negative third, notice x isn't in the exponent, 5 pi, x isn't in the exponent, 1 to the x, the base is 1, which it's not allowed to be 1. Sketch and analyze graphs of exponential functions. Sketch and analyze graphs describe the domain, range, intercepts, asymptotes, and behavior extrema where the function is increasing or decreasing. We can make a table for f of x equals 2x. We can also take a look at it in our graphing calculator. If we were graphing this on a table by hand and wanted a more accurate sketch, we would do, and you've done this in Algebra 2, you did this, do several different values. 2 to the third is 8, 2 squared is 4, 2 to the first is 2, 2 to the 0 is 1, 2 to the negative 1 is 1/2, 2 to the negative second is 1/4, 2 to the negative third is 1/2 cubed, which is 1/8. So if I'm looking at a sketch of this graph, there it is. It comes down and it has something that are rational functions. It will shoot up infinitely to the right. As we go to the right, it'll shoot up infinitely. But as we go down, it gets incrementally closer and closer and closer to 0. So you can see that on this graph. It's getting closer and closer to the x-axis. And do zoom 6. So we know the domain of this function is all real numbers, negative infinity to positive infinity. The range of this function is from, but not including 0, to infinity, because it shoots up infinitely. It gets close to 0 but doesn't touch it. There is no x-intercept on this graph. There is a y-intercept at 1, because 2 to the power of 0, any base raised to the power of 0, is 1. There is an asymptote, a horizontal asymptote, at y equals 0. That's why this is getting infinitely closer to 0 on the left-hand side. There are no extrema, and the end behavior is that the limit on f of x, as we go to the left, it gets closer and closer to 0. As I go to the right, there is no limit on the end behavior. It grows infinitely in a positive direction. And parts of the domain for which the function is increasing or decreasing, if you put your little dude right here, he's walking from left to right. He's constantly walking uphill. Negative infinity to positive infinity, increasing. Let's take a look at what happens when the exponent's negative and we take 3 away. First off, let's look at what happened if we just took 3 away. Just taking 3 away shifts all the y values, all of the outputs, down 3 units. Remember translations from Algebra 2. So this means that our horizontal asymptote would no longer be y equals 0, but would be y equals -3. But I didn't change the exponent yet to be the opposite of x, so let's see what happens when we do that. Now we have a reflection across the x-axis, across the y-axis. Instead of coming up over here, it comes up over here. Instead of coming down on the left, it comes down on the right. It flipped across the y-axis, and it shifted down 3 units. So now our domain for exponential functions is still negative infinity to positive infinity. This time, though, instead of our range being 0 to infinity, because it was shifted down 3 units, it will be -3, but not including -3, and then rising infinitely on the left. There is an x-intercept, I believe, at -2. Let's take a look. Nope, that's -2, 1. Let's find that value. We'll have to learn how to solve. Let's do this right now. Calculate the 0, because we have to teach you how to solve these. You might not remember from Algebra 2. So right now our 0 is approximately negative 1.584963. It's a rational 0. And then our y-intercept is going to be, when we plug in 0, negative 2. So again, 2 to the negative, or 2 to the 0 is 1, minus 3 is negative 2, so that makes sense. For our asymptotes, this time there's a horizontal asymptote at y equals negative 3. There are no maximums or minimums, so no extrema. The end behavior, as we go to the left, it rises infinitely. There's no limit on the end behavior going to the left. But as we go to the right, it's decreasing, but it's constantly getting closer and closer to negative 3, closer to this horizontal asymptote. As far as increased intervals in which the function is increasing or decreasing, if we draw our person walking from left to right, they'd constantly be walking down. So from negative infinity to positive infinity, this is decreasing. Completes our table. Recalling transformations from Algebra 2. So your pre-calc book calls it something different, but I stick to what you learned in Algebra 2. On this function, we have our function being f of x. In this case, it is b, because it's a base of an exponential function. The parent function is b to the x. Well, now we have a multiplier in front. That scalar multiplier in front is a. And in Algebra 2, you learned that a does a couple things. If a is negative, it will give a reflection across the x-axis, which is actually a vertical translation. Because instead of a point being up here, it's now down here. We've moved the point vertically. So A is vertical. This is all going to be vertical stuff that happens, stuff that affects the y-coordinate. If it's opposite negative, it's a reflection across the x-axis. Whereas, and also if A is a number greater than 1, meaning it's not a fraction, then it is a vertical stretch by scale factor or by factor A. So if it's 2, then everything is 2 times as high as it was before. Whereas if A is less than 1 but greater than or equal to 0, well, no, not equal, greater than 0, less than 1, no equality. Less than 1 or greater than 0, meaning it's a fraction that is smaller than 1, like 1/2 or 1/3 or 3/4, then it is a vertical compression of whatever the factor A is. So if A is 1/2, then everything shrinks its height by 1/2. It's a vertical compression of 1/2. Also affecting the vertical height is the plus k. We just saw that with this last one. We have the function and then we took 3 away from all those values, which shifted everything down 3 units. This is going to be a shift up or down by k units. So if you see a -3, it shifts down. If you see a +3, it shifts up. Our next one is a little trickier. We have this little b next to x. And this little, or our next one's little h, -h. Some of you remember, well, we saw this one, if b was negative, if b is negative, then it is a reflection across the y-axis. It's considered a horizontal because it moved from the right to the left. So these are horizontal translations. So this one, the negative on b, means that it is a reflection across the y-axis. With that, if b, it's a little counterintuitive, if b is greater than 1, if it's a number like 2 or 3, then it's actually a horizontal compression by the reciprocal value. Horizontal compression of 1 over b. Whereas if b is less than 1 and greater than 0, so we see that fractional value for b, then it's counterintuitive. We see a fraction, we think, oh, it's going to get smaller, and in fact, instead it gives us a horizontal stretch of 1 over b. So let's say that b was 1/2, or sorry, let's say that b was 2. It won't be a stretch. It'll be a let's say that b was 1/2, sorry. It won't be a compression. It will be a stretch of 2 over 1, the reciprocal value. And now we need to look at letter H. Letter H, whatever sign is on it, we do the opposite. This will be left, right or left, using the opposite sign of what we see on H. Opposite of what we see. Because it's all counterintuitive. If it's in the exponent, if it's a multiplier in x or added or subtracted with it, it is counterintuitive. Now, in fact, we'd actually have to factor b out first, and we'll talk about that as we go, but I don't think it's going to be relevant in this chapter. For now, you're either going to see a multiplier in x or addition or subtraction with x, but when we have them both, we have to be careful. In your next video clip for day 1, we will look at these graphs, and we will describe all the points we're supposed to and talk about how they're transformed. Feel free to take a minute to look and see if you think you can describe the transformations before you watch that video clip. In that video clip, we will also look at graphing functions that have a natural base, but this concludes clip 1 of the day 1 notes for lesson 3.1.